good morning, good afternoon, good evening, maybe even, what is applicable to you. Thank you for joining today's webinar. We are excited to show you all the new features that we have been working on the past few months to improve our Medis Suite MR product. Today I will go over the new things that will be in the release, the major and the minor changes, and those minor changes I will show you afterwards as well in a live demonstration. Well, as always, we aim to have or to create for you a MR solution which you can use daily for your post-processing. And each time we try with a newer version to get it more efficient for you guys, to add quantitative analysis and to make it even more robust platform. And this time you will see this back in the following parts. So for the efficiency, we have embedded an improved or upgraded deep learning algorithm to create the LV and RV contours. And with that, we have also improved our workflow for the function analysis. So this will go quicker and with less adaptations needed for the contours to get your values in there. I will elaborate on each of the items in a bit more detail later on. Then for the analysis, we have added two parts in our 4D Flow application. One is a phase unwrap to overcome, or if there's aliasing present, that you can unwrap it so you can process your data set without any trouble. And the other part is the 3D streamlines. Previously, we had embedded 2D streamlines or streamline lines in their 2D representation, and now it's also available in the 3D part. We'll show you that as well, of course. And then at last, maybe a bit more IT based, but also very important for your platform, is that we have added role-based access control. So the right people get access to the right parts in Medis Suite, for example, anonymization or removing data sets. And to make the application understandable for everybody, next to the English language, we have added 6 different languages, both in the software itself as well as in the user manual. So I will go over these items one by one. And if you have questions in between, please use indeed the Q&A button below or write it in the chat, and Anna will update me if there's any question in there. So first, then the efficiency part. The deep learning part has been upgraded. It has been trained on additional cases, and especially on a lot of Canon cases. And interestingly, this has resulted also in a better contour detection, for example, for pediatric cases or cases from other vendors than from Canon. So the initial feedback that we got from our customers, which we wanted to get some feedback on it and how it had improved on different cases, is that it was actually very much improved, and that currently they only need to change some limited slices and often only in either the base or the apical slices. Also from the pediatric sites, we got very good news that with this algorithm, they don't need to draw them manually at all. They just can change it a little bit. You're seeing here in the screen an example of one Canon case where you can see clearly the difference between the pre-contour detection algorithm and the one afterwards. The differences won't be that large for each data set, especially if the contours were already quite good, but especially for the Canon cases, you can see that there's a huge change in there as well. Then next to that, to have this embedded in a better way workflow-wise, we have done 3 different things. So the first thing is that now when you open a QMass application to do the function analysis with your short axis, it will automatically recognize the AutoQ file and it will show you the contours directly. The second thing is that it will now by default show only the ED and the ES face. You still are able to see all the different contours from all the faces, and you can set this as well. So if you have a preference that you would rather see all faces with the contours, then this can be set as well. The default is that you will see only the selected ED and ES face. And then at last, the ED and or ES face can differ between the LV and the RV. And previously only the LV parts were shown, and now those can be changed individually. Might be a bit small here on the screen, but you can see here that, well, in this case, it's both at the same face, but it still differentiates in the LV and the RV. So this you can also change individually. So if afterwards you see that the RV is on a different slice, you can still change that. So previously we had already generated the automatic generation of the AutoQ file, and now also the automatic loading and default ED and ES face has reduced some clicks, and that feedback is what we are getting back now for this as well. So I hope this will save you some time doing your function analysis in the future. Then going to our quantitative analysis, what we have added in there. Both are the options for the flow. And the first one I want to talk to you a bit about is the face unwrap to correct for aliasing artifacts. With one button, it will detect and unwrap it automatically for the whole series, so for the whole volume. If it's too much wrapped and the default settings are not working good enough, then there are still in the background parameters we can change during our analysis to make sure that all the wrap is or all the aliasing artifacts are unwrapped. So we do see sometimes, especially when it's scanned for lower vein, so when you're less interested in the aorta and in the pulmonary artery, but more in, for example, the vena cava, and you are really looking for the lower velocities in there, that you will see, of course, then the aliasing in the larger vessels where the bank is too less, but still will be able to correct for the ones in the lower bank parts. Well, in addition to this application, or actually we see that there is an artifact which looks a lot like if it's aliasing. However, it's not based on aliasing. It has to do with the way that the data set was reconstructed. And this is part, or is seen a lot in the older Philips software version, and it's called Hadamard. And this cannot be solved by this face unwrap thing because it's not a face unwrap artifact. There is already a newer version available, and we advise you to switch to that. So if you see artifacts in your Philips data, which looks a lot like aliasing, but it isn't, then please contact your Philips contact person to make sure that you can switch to the newer version of their software. So this can be fixed for you and you get the right results in the different claims. This tool has already been found very useful, especially in the pediatric sites. And with this, it is really a clinical application which you can use now for all different cases. It's really easy that you only need to press on one button and it will automatically distribute the unwrapping part to the whole data set. It will also distribute it to the analysis that you might have already done. So if you had already done an analysis for this frame in the QFlow2D application, then it will also be updated afterwards. I will show you that as well in the demonstration. Then the second part in the 4D Flow application is the 3D streamlines. So previously, the 2D streamlines were created and we're able to see them in the different views. But in the 3D image, you didn't see any of those streamlines. Now you will see the streamlines based on the field where you can also make an analysis from. So this is basically the plane where the streamlines are coming from. And let's replay it. You can move this field, of course, to each level or to each location where you want to see the streamlines of. So now we're switching from one vessel to the other. And here we can see now for the aorta, the streamlines going through there. So this will give you some better visualization of how the path or how the streamlines are going in the different vessels. So if there's still no questions regarding that, then let's continue to the platform part. So one part is the role-based access control. This is a bit more technical, IT related, but I hope, or might be that there are also some more IT related attendees today and you're in the call, so I do want to mention it. And otherwise, you might mention it to your IT, so this is available for them to use or to set up. What it means, this role-based access control, is that the differentiation can be made between the users of Medis, of the Medis Suite software. So, for example, it might be that not everybody is allowed to delete a case or to anonymize cases, and this can then be separated. So different groups can be made to see who is allowed to do what. So, for example, as an example, you can make the differentiation between clinical users, research users, and IT operating administrators. So each of those groups have different roles. So, for example, in a clinical case, maybe you don't need to anonymize the data, but for a research person, that's very important to do so. So the different functionalities where we can define them are described in here. So probably everybody of you will have the general part to start up, to view and to analyze the data sets, but maybe not everybody is allowed to import data to the repository. I can imagine if you have an intern working that they might not be allowed to do that, or they are not allowed to export the data and stuff like that. Then the other part that has been changed in our platform is the languages. And for all clinical applications, the user interface and the user manual are now available in these 7 different languages. So to make sure that all our users understand the software, probably the majority did understand it in English, but we want to make sure that also in your mother tongue you can understand the software, and it will probably be a bit easier to grasp how the software is working and where to click, and what each of the functionality does, or what the output will be. So these are the major updates in the upcoming release. Then there are some more minor things which are a bit difficult to show you, but I do like to mention them to you because I do think they are nice to know. So the query and retrieve possibility has been improved in such a way that it's almost up to 50% faster than it was before. So if it took you previously 2 minutes, then it will now only take you a minute to retrieve the data. And secondly, it will also be maybe a bit more IT related, but the way that MediSuite claims a license is now a bit different. So MediSuite will only claim a license once you open or load a patient. So when you just load the MediSuite environment, not a license is claimed. So when somebody is just opening and not doing anything with it, everybody can still use all the different licenses. So also the IT can change the settings or can make some changes, or maybe our support team wants to have a look at how everything is set up, and they won't claim a license or don't need to ask other users to close the application because they cannot enter it. And then the last one, which is also a very interesting one, is that now for all clinical applications, the output is also available in DICOM-SR. It also sounds a bit taggy, but what it actually means is a DICOM-SR is an output measure or way that can be your own reporting system can listen to. So for example, we can export this to Modlink or to PowerScribe, and to make it possible to get our data directly in your own reporting system. So you don't need to copy and paste all this information. So those were the additional enhancements that I wanted to mention to you as well. I don't think any questions yet. So if you have one, please do not fear to write them down. There is plenty of time for me to go over them. But then I do like to continue with a live demonstration to give you a bit of feeling of how these different things look like in real cases, and where to click, etc. So let's continue to the MediSuite part. So let's first go over the function analysis. I won't go into detail into the part on how to get the contour, the AutoQ file. This has remained the same, but I do like to show you a few cases so you have a bit idea of how it's working on different data sets. So when the case is loaded, we can load different data sets into QMass, but if we just load the short access, it will recognize that there is a AutoQ contour file present and will load that directly. As you can see in here as well, it will load only the ED and the ES faces. And in this case, it also has made a differentiation between the LV and the RV ES face. So it will show the contours at both faces. Let me show you the contours in here so you have a bit idea on how it's performing. And also for the ED face. So with that, all the information there, we can still edit it as you're used to. And then in the report, you will find all the information of both LV and RV. So let's show you two other examples. So here another case. So here as well, you will see that it has loaded it automatically. I didn't need to select the AutoCue file itself. It has been there already. Now, if you do want to change the location, so for example, if you want the LVED phase to be the first one, then we can still drag and drop it in, and then it will remove the other one. So in this case, you will see it has been disappeared in here.
Kaylee, there is one question. Is it possible to copy a stack ED to LGE images, not one by one image, but the whole stack?
Thank you for that question. Actually, we have a transfer button in the LGE application. So if I load here now the LGE case, I think this is the LGE, right? Yes. And we switch here to the late signal intensity. You'll have your transfer button, which will then transfer the contours of the short axis towards the LG images. So let's make sure that it has all of them in, because it will select the time frame that has been the most equal. So you see that the image has been a bit shifted. So we can still change that. A bit more modifications are needed, I see in this case. But this way we can use the contours of the short axis to our DSI analysis.
Kaylee, there is one other question if you're done with that.
Mm-hmm.
Is there a way to permanently have peak velocity on the report?
Thanks for that question. We get that question a lot. We are getting onto the next phase. So in this version, it's not possible. You only can add it manually each time. But we are looking into a way to make this possible, to make it a default. So thanks for mentioning it again. It shows indeed also to everybody how that is really a wish from the customers. So it should have high priority. So yes, we are working on that. It's not embedded though in this version. I did show you now how to do the all phases, but let's do that again in the last case I'd like to show you. So the last case is a bit harder to do. It's a bit more difficult case. You will see based on the images as well. So you see here the image quality is not as good as the other ones, which makes it harder to get the contours correct. So let's first show you the contours on how they are in this case. So as you can see, they are there might be some changes that needs to be done, but overall they are good. So here maybe you want to do some changes. Other than that, for the quality of the images, you can really see that it's going well. So as said, we can show you by default all the phases. If you the majority of the time only wants to see the ED and ES phase, but sometimes do want to see all faces or all the contours for all the faces. Then we still can do that by dragging and dropping the AutoCue file in with our Shift button pressed. So this way you can still see all faces in here as well. Okay, unless there are any questions regarding the function analysis, let's continue then to the 4D flow application.
Kaylee, there is another question. Does the auto contouring always exclude papillary muscles?
Thanks for asking. Yes, it does. It's always will be part of the blood pool. This is how the guidelines currently still provide it, or how to say, the guidelines mention that it would be better to have them part of the blood pool. However, there is an easy way that we can get them extracted from the blood pool. So when I open a case again, you can see indeed that now they are part of the blood pool. In the functional analysis tab, we have a module called the Mass K mode. And when we check that, you can see that now the inside has been colored green of the myocardium, but also the papillary muscles inside are now colored green. And everything which is colored will now be seen as mass and will be extracted from the blood pool. So based on that, you will get also the amount of trabeculae or papillary muscles, and the mass has been changed, and also the ejection fraction has been changed based upon that. So yes, it will always exclude the papillary muscles, although there is a possibility that you can also use the Mass K mode to get the papillary muscles not part of the blood pool. I see that there is another question regarding the Mass K and in the RV. So for the papillary or for the Mass K mode, we do need the epicardial contours, and therefore it's not showing it here automatically because only the endocardial contours are shown or drawn. So if I change that, then you would also see the papillary muscles here in the right ventricle. So if you do want to get the papillary muscles as part of your analysis, then in theory you only will need the epicardial contours. So the endocardial contours are not necessary. What is also a bit tricky with using the Mass K mode is the normal values. So all the papers describing the normal values are not or are seeing the papillary muscles as part of the blood pool. So there is currently no paper available which excludes the papillary muscles from the blood pool. So therefore we don't have normal values embedded by default, although you can still choose one of the different papers that have been around there for the calculations with the papillary muscles embedded in the blood pool. I hope that answers both questions regarding the papillary muscles or the Mass K mode. Then let's continue to the 40 flow application and show you the aliasing in there first. So sometimes it's hard to see up front if there's aliasing in a dataset present. Well, in this case, I can see already a bit of the aliasing in here because the black dots in the white. But also in the 40 flow, in this case, it's quite easy to see that there is some aliasing present. So let's first get rid of the noise and do the background correction. And then you can see actually in here, you can see that there is a weird band. I hope you can see it a bit. So that's where the aliasing is present. So when we go there with our crosshair, you can see it now here appearing very well in this orientation, that you can see really those white pixels in black. So if we would do an analysis now with 2D flow, you will see here in the volume curve already, but especially in the velocity curve, that at a certain time the velocity is completely the opposite as the other time points, so that there is something going on. And of course you want to avoid it because we cannot measure it here correctly. So if we now go back to the 40 flow application, we can here do the phase unwrap. So the button is described over here, and the phase unwrap will correct for the aliasing artifact. So with the default parameters, it will do it for the whole data set, and it will also automatically upload our flow measurement that we already did. So you see now in here that we don't see any white pixels anymore in the black, so it's been completely solid in here. If we return to our flow measurements, you will see directly that the volume curve has been updated, and that is now a nice round curve. And also for the velocity, we'll see beautiful curves in here. So to make this measurement more reliable. If it hadn't worked completely, if there would still be some white pixels in here, in the settings there are still options to change that. So we have either the possibility that we'll see white pixels in black, or that you can see black pixels in white. And depending on that, you will change either the upper or the lower threshold to make sure that those pixels are also unwrapped. So in this case, the default settings will do, so I won't change anything regarding that. So to show you the streamlines in here in this case as well, I can switch here from speed to streamlines. So then you will see the streamlines in 2D as you are used to or have seen before. But now in addition, you will see here also the streamlines in 3D in our 3D viewer. And this will be the orientation of the analysis. So where the crosshair is located for your analysis plane, so the green part. So it's also why we are showing it here as your green plane. So you can see here part of the aortic curve. We can still move our plane, of course. So if we want to see more at the ascending part of the aorta. We can still change the different locations and show you more the whole arch of the aorta in there. So we can enlarge this plane as well. We can rotate it. And with double click also make it smaller again. So let's show this as well in a different case. In that case, you can a bit better see that if there are aliasing parts in different sections of the data set, that it will do the changes in all of them. So as you can see, quite large data sets. What works a lot to get the opening and loading into the application at a reasonable time. I can feel already that I'm also broadcasting it, that it's a bit slower on my system, but I think still a good speed overall. So let's do the background correction and the noise removal. And here you can see a bit less obvious, but still present, also some aliasing artifacts. You see them a bit smaller and more differentiated. So not one spot, but multiple spots. So a bit harder for me to get it to the right plane so we can see it in here. But I think, got it. So here you can see now the black spots in white. And with the button, it will change not only in here, but also the region that you saw on the other part, a bit lower part of the pulmonary artery are now both disappeared. So you see now solid white and no black spots in there anymore. Also in here, let me show you the streamlines in there. So you can see here a bit more than in our previous case that there are a lot of lower velocities that are also visualized. And to focus really more on the higher velocities, we can a bit remove those lower velocities. So instead of watching from 0 to 200 centimeters per second, I want to only view the 20 to 200 centimeters per second velocities. So you see a bit less noise in there. Oh, and also in here we can easily switch to different facet to have a look now here in the aorta, where you can nicely see the candy cane in here now.
Katie, there's a question now. Should you always use the anti-aliasing unwrap button even if you do not see any, or is there a downside?
So wonderful question there. You can, if there is none, then it won't do a lot. It will check the data set, but won't change a lot. However, it's still important that you try to scan on the right fang, especially if there is aliasing. Then similar to with 2D flow phase unwrapping, you will basically miss then if the fang should actually be higher, then you miss a bit of the lower fang or lower velocity information when you do apply the phase unwrap. So in theory, there won't be really a downside to do it. It might be that you get a little bit less information of the lower velocities if there is a little present. It's not if you are doing your measurements and you only find out with the last one that there is aliasing in there, and you still do it afterwards, it will update all the results of the previous done analysis. So both ways will work, I would say. Either do it when you face it or when you want to do it upfront.
Now there's another question, this one for 4D flow. What is the preferred background phase correction and is it necessary?
So another good question. So the background correction is like in 2D flow applicable to certain fender types. So for Philips data sets, it's not necessary, but for Siemens, it's advised, for example, and for GE as well. For 2D, they sometimes scan also with phantoms instead of doing a background correction, or using that as a background correction mechanism, I should say, actually. So yes, it is advised to do it, especially a bit depending on the vendor you have, though. There is a difference in measurement power, basically, or measurement time that is needed to do either first, second, or third degree background correction. The preferred way is a bit depending on whether you have a 4D flow or a 2D flow. So if you have a 2D flow case, then first degree would be good enough because you only have one plane. For a 4D flow, they advise to do at least a second degree and prefer a third degree. It will take a bit more time to run the algorithm or to analyze it. So that's a bit depending on your wishes, if there is a time, but yes, we advise to do a third degree for 4D flow cases, especially for Siemens or GE datasets. So we can set also the level of background correction. And this will then also stay put for the next time, so it won't. So next time it will by default do also the third degree for each of them. So thanks for these nice questions. What is left are the things for the platform. It's a bit more technical, but I do want to show you where it's located. So in our options dialog, at the general part, this is maybe more applicable to the majority of you, you can change the language. It will change it directly so you know that it has changed and what it will do. So it's also easy to change back if you made a mistake and just hit the button accidentally. So this will go for each of the different languages. If you have applied it, then it will still be preferred to close Medis Suite and run it again. So it will apply this new language to all applications. So currently it can do the parts that you're seeing, but it might have missed a few fields. And it will be saved on the person. So in theory, only the person who set it to Spanish will see everything in Spanish, and the one still preferring English will keep it in English. So let's move it back before I don't understand what I'm doing anymore. Then the second one is regarding to use the role of the users and roles. And you can have different roles applicable. So for me, I have just created a few to give an impression that there are different ways to do so. You can, for each role that you have described, so for example, research or interns or IT or depending on the wishes of your hospital, of course, you can select the different groups of your hospital. So all the Active Directories that are present will be listed here. So currently I'm not connected to the Medis Suite network, but otherwise in our Medis Suite team, we have support team, and we have a development team, and we have an administration team. So each of those teams will be listed then in here, and each can be given different access to the different groups.
Kaylee, we have a question here. Is it easy to apply the institution logo to the Medis report?
Thanks. Yes, that's a really easy setting. Let me finish this up and then I will come back to that. So once you have set different Active Directory groups, maybe radiologist or cardiologist or maybe something in between, then you can define which of those roles are allowed to do which functionalities. So are they allowed to anonymize the data or are they not? Are they allowed to delete the data set from the repository or not, etc. So this way it can all be set up. I know it's a bit technical, but I hope you got a bit an idea of what it can do, and if there is a need in your hospital to have such a role-based access control, that you will forward it to your IT department so that they can embed it for you. Then with regards to the institution logo, it's in the reporting part here in the options, and here you can embed your logo of your hospital institute. Even if you want your own picture on it, it can be done. You can also set the organization name, so everything will be fit to your hospital. Okay. For me, these were all the things that I wanted to show you. And I think if there are no other questions, I'd like to conclude this webinar with saying thank you all for joining. I hope it has been useful for you to see the new features. Shortly, all the people who have will be allowed to upgrade to the newest release. Will get an email regarding that, so everybody can be up and running. The recording of this meeting will also be sent by you, and if you have any questions still afterwards, please don't hesitate to contact us. You can email to our support, which is support@medisimaging.com. So thank you all, and have a good day.